Hello students, today we are going to see the chapter 3 under Aldo and Faisal textbook, and the topic we are going to discuss today is norm. So the definition is kind of important, so please study the definition because they will ask in the exam. So a norm on a function on a vector space V is a function where the norm or the dot magnitude of dot is given by V given R. I know it is kind of difficult to understand this thing, so we'll see what is norm. A norm is a function that assigns a non-negative number to each vector in the vector space. Okay, so this number can be the size, the length of the vector. Okay, please remember this, and we always represent the norm with the double lined straight lines with the x in between, that is a vector, again the double lines. Now how does this norm work? Okay, how basically what happens and why we how we are going to solve it. So it has something called as input and it has something called as output. The input will always be the vector, so the input will always be the vector, and the output, and the output will be always the real number, and which is a non-negative number. Okay, and which should be a non-negative number. Please remember these points. All right, now let us go to see what are the properties of the norm. Okay, this is kind of important. If you study it is good, and you'll know how to solve the problem. So what is the first property? The first property is absolutely homogeneous. Nothing is there, you don't have to study any definition, you just directly have to study what is the formula of it. Okay, suppose you have the norm of lambda into x is nothing but it is the lambda lambda into the norm of x. Okay, from here I will tell it as norm. Okay, if you see it all double straight lines. All right, now what is the second property? Okay, that is triangle inequality. So it is nothing but norm of x plus y is nothing but it always should be less than or equal to norm of x plus norm of y. Okay, this is triangle formula, that is triangle inequality. The last but not the least, it is positive definite, that is nothing but it is the norm x always should be greater than or equal to 0. That is what we have discussed, it should be a non-negative number. All right, these are the three properties that the norm has. Let us dive into the next section of the video, that is how many kinds of norms are there. So basically there are many kinds. Precisely we are going to study two kinds of norm. In that, first one is our Euclidean norm, and the second one is the Manhattan norm. Directly we will see the the formula for it, and will not waste any time. So the formula for Euclidean norm, please let me write it down. Euclidean norm is nothing but it is it is yeah, please, one second. Yeah, it is the norm of x is equal to root of summation of I is equal to 1 to n xi square. Okay, so if I try to write the xi square, what it will happen, it is x1 square plus x2 square and so on up to xn square. That is nothing but the Euclidean norm. So norm of x is equal to nothing but that formula for Euclidean norm. All right, so let us see what is Manhattan norm's formula. So it is nothing but norm of x is equal to, it is summation of I is equal to 1 to n, and it is the mod of x. All right, now xi, sorry. Okay, now if I open it, what will happen? It is x1 mod of x plus mod of x2 plus mod of x3, so on up to mod of xn. That is norm of x. All right, yeah. So now let us see the example. Okay, let us take one example. Given a vector v is equal to 3 4, and find the Euclidean norm. Okay, please remember, if they ask Euclidean norm, then you definitely have to apply the same formula. But if they just ask for norm, please assume that they are asking the Euclidean norm and apply the Euclidean norm formula. Okay, please don't mess it up, and don't apply the Manhattan unless they ask it. All right, so let us solve it. What is the formula? It is nothing but the norm of v is equal to root of v1 square plus v2 square and so on up to vn square. So we only have two numbers, that is 3 and 4. It is nothing but 3 square plus 4 square. All right, so the square of any number will be giving you the non-negative number. So the norm of v is 5. All right, so that is I can also call it as a length. Okay, please remember it is also called as length. Okay, so now let us see one example for Manhattan. Now we know what is Euclidean norm. It is very easy, you can solve it. Now let us see for the Manhattan. So given a vector w, so let's take w and -1 2 -3, find its Manhattan norm. Mn, I'll write. Okay, so what is the formula? Directly w sorry, it should be norm, right? Yeah, so please write it down. Norm of w is equal to mod of w1 mod of w2 so on up to mod of wn. So if mod symbol is there, I hope you know it. If negative is there, then it will become positive, right? So mod of -1 plus mod 2 plus -3 will be nothing but it is 1 plus 2 plus 3, right? 1 plus 2 plus 3 and you will get the answer as 6. All right, so now I think you can clearly solve for what is norm and two kinds of norm. Let us wait for the next video, that is I'll be going to do on inner products. Thank you.